Good morning, everybody. Ooh, it's really bright and early this morning. I'm back in my jacket. Dr. Cole speaking. Hey, Tuesday. Anyway, I want to get back to our very important notes I've been studying about what I want to teach you today. So today, if we were in school, this would be very cool because I would be doing some dancing and jumping around. I'm not in school. So I could dance. I like to do that. But so yesterday we started on matter, and I was telling you that there were three kinds of matter. Well, really four, but three that we're going to talk about: a solid, a liquid, and a gas. So I'm thinking, what's the best way to show everybody this? So, while I was eating my breakfast this morning, I had Captain Crunch. I got thinking, I think I can show them this very easily. So, if you're a solid, here's my bag of Captain Crunch. Everything, this is a big secret, everything's made up of atoms, okay? Atoms are the particles that I'm talking about. So here's a bag of Captain Crunch cereal, and they're very tightly packed together. All these little particles, pretend they're atoms, whatever you want to pretend they are, they're very closely packed together. They're hard to maneuver, okay? So if I were thinking of this as a solid, think about my cup, okay? Again, a solid. There's nothing in here that's really moving, okay? This nail file, a solid. It's not going to move anywhere, okay? So when you think about a solid, I want you to think about how tightly everything's packed together. Now, does that mean they're not moving? No, they're still moving a little tiny bit. But they're not moving a lot because they're really close together. So think about if you were in a really crowded room and everybody was squished together back in the day when we could all not have 6 feet apart. Then you were squished, you would be like a solid. Like think of sardines in a can. I could get some of those for you and show you that as well. But they're stinky. So anyway, that would be a solid. So then if you looked at a liquid, okay, which one's my liquid? This one. Okay, so now my liquids, they have a little bit more leeway. They can move around a little bit more. They're not so tightly packed together. Okay, so they're not. They're just kind of floating around in here. So if I have a liquid, it gives it flow. So think about pouring milk out of a container. Or I have water in here. See, there's a flow. There's a movement. See it? Ooh, that's kind of cool looking. Yeah. You can see the colors of my shirt. Mrs. Enos thinks I'm always wearing my night dress when I wear this shirt. Anyway, back to science. So now, liquids gives them that flow. Solids, no flow. You're just pretty much stuck. Okay? Now, when you have a gas, all around us, hello gases, okay, they're here, everywhere. They would be moving really quickly, because they have a whole lot more room in them, so they can really scoot around. They got a lot of room. They don't typically, I should really only put like 5 in here. They don't typically need to bump into each other very much because they're just everywhere. They're all over the place, okay? So that makes it a solid. Not a solid. That makes it a gas. So you have your solid, really tightly packed. Your liquid, not so tightly packed, still have some space to move around, gives it that flow. And then you have your gas, which has a lot of room to move around. Okay? So one of the things I want to tell you about is water, because water is what you call super special. It is. We're supposed to be drinking it every day, 8 glasses. How many of us do that? I don't know. Some of you might. But solid can be in a solid, or water can be in a solid. It can be in a liquid. It can be in a gas. So yesterday when you watched my video, the first thing I showed you was steam. That's when it turns into a gas. It's evaporating and turning into another substance, but it's still water, and it's still going to be in your house. So all of us who need a humidifier, let me see. Here, I'll show you, because this one is, this humidifier is working like overtime because of our wood stove. So if you can see, right here. Can you see? Okay, there's steam coming up. And the steam coming out of that is what's going to hopefully gives us a little bit of fluid, or a little bit of fluids, yep, in our house, which in here is water, which is turning into a gas. Okay? Hope you could see that all right. I don't know. So then you have ice, which yesterday everybody was slipping and sliding when we were driving to work. So you have your ice cubes. Whoops, sorry. So you have your ice, okay? So you have your gas out there, your liquid in here, and this. The thing about this, it's kind of like a big secret, really, not really, but ice, instead of it getting really tighter together, they kind of move apart a little bit. That lets them float. So when I put, well, I can't do it in this. When I put an ice cube in water or in soda, it doesn't go to the bottom unless I fill the glass. It floats. See my ice cube? Let's see if you can see it. Whoop, sorry. My ice cube's floating around in there. So, water's pretty special. It can take all three and continue going back and forth to what they are. So that's pretty cool. So, the thing you have to remember about today's lesson is this: solids, liquids, and gases. Now, things are really tight together. Things are a little farther apart. And then things are really far apart. So, how do we know how to distinguish? What are the physical properties? Let's go back to scientific method. The very first thing we did in scientific method was observation. So, we're going to see if we can hear it. Can I hear this? I sure can. Yes. Can I hear this? Oh, I sure can. Can I hear this? Yes. Oh, I can hear. I could probably make some music. Dun 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 dun. Okay. Can I smell it? I sure can smell these, because that's what made me want to have them this morning for breakfast. They smell like peanut butter. Can I touch it? Yeah. I'm even made of a solid, so yeah, can I touch it? Absolutely. Touching, touching, touching. Okay. Tasting. Can I taste it? I don't know. Let's see if I can. I'm going to take one of me. Oh, I'm going to take a few of these because they're so delicious. And I'm going to taste them. All right? Can you hear that crunch? Oh, my God. They're so good. Good choice. Okay. And then, I'm using all my senses. Can I see them? I can see. Okay? Those are what you call physical properties. Physical properties. So, if you can do these things, now can I touch water? I can touch water, but it feels way different than my countertop here. Can I taste water? Kind of tasteless, unless I put something in it. Can I see it? Sure. Can I smell it? Water doesn't have not much of a smell, but it's there anyway. So, tomorrow, we're going to talk about what we can do with all these solids, liquids, and gases. How can we put them together to make something called a mixture? So that's going to be tomorrow. Since I'm taping by myself today, as you can see, I'm not doing a great job, but I'm doing a job. Anyway, I miss you guys, and I'm hoping that you understand this solid, liquid, gas using the physical properties of it, which are hearing, smelling, tasting, etc., etc., etc. So I'll see you guys again tomorrow with some more fun. You're going to actually get a little glimpse at my plant. Whoop, if I can find it. There. Which is a mixture. Have a great day, you guys. And remember, be kind to one another. Kinder than necessary, and don't drive your parents crazy. All right. Talk to y'all tomorrow. Love ya. Bye.